we're again looking at slopes of lines and segments, and in part two, we're going to look at slope as an average rate of change. So a little bit different than calculating with coordinates or equations or whatever. We're going to go back to that table representation of functions. So what we're trying to do is find out how much does one quantity change compared to another. That's what an average rate of change is. The data that we have here is not linear data. There's absolutely no doubt about that. However, we can make an approximation of it as a linear data, and that's what the whole point of average rate of change. We're effectively calculating the slope between 2 points. So we're going to have this, curve with a lot of different values, and we're trying to make a linear representation out of it. So use the following scenario. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, from 0 to 6, is given by the function c of t, where t is measured in minutes. That's going to be huge here. If I see anything about units, I want to highlight that or make some kind of indication because I know that's going to be there. Selected values of c of t measured in ounces, so there's another unit, are given in the table below. So we have a lot of different values here. All right. So part one for this problem, we want to find the average rate of change of the liquid from t equals 3. Actually, let me use a different color so we can see the process here. T equals 3. So here's our stuff at t equals 3. And to t equals 6. And here it is. So basically what we want to do is find out what's the slope between those values. So to do this, what I'm going to do is find the change in my outputs. These are my outputs here. C of t, which is the amount of coffee in the cup at the time. And then t is our input. Oops. So when we're dealing with slope, another way to think of slope is change in output. There we go. Change in output over change in input. Okay? So what we want to first do is figure out how do these outputs change? What's the difference between 11.2 and 14.5? And I'm calculating that I've got a plus 3.3. I'm going to do the same thing for the inputs, which are time. And by the way, time is always an input. So if you have some problem with time, you cannot control time. So time will always be an input. So 3 to 6 would be a plus 3. So when we're finding the average rate of change, we're going to do 3.3 over 3. And we're going to reduce that down because it's one that's easily reduced. 3.3 divided by 3 would be 1.1. So we have part of what we need, but we also need to include units in our answer, and this is why we highlighted those above. So again, our output was in ounces, and our time was in minutes. So this is 1.1 ounce per minute. And that's our average rate of change. Part 2 of that question says, using correct units, explain what that means. Explain the meaning of your answer within the context of the scenario. So when I have average rate of change, here's what I'm always going to say when I have a question like this. I'm going to start off with on average, because this is an approximation. It's not exact over all time periods. It's just on a particular time period. So on average, the amount of coffee in the cup, and this is where we're going to talk about an increase or a decrease. And this average rate of change will tell us that. Realistically, the change in output will tell us that also, because normally our input values are going to go from lowest to highest. So I'm seeing an increase here. On average, the amount of coffee in the cup, because it's a positive average rate of change, increases. If it was negative, you'd say decreases at a rate of 1.1 ounce per minute. So from t equals 3 to t equals 6 minutes. So what do we need to have here when we're answering a question like this? Well, first of all, we need to have something about it being an average. So on average, we want to talk about an increase versus a decrease. What the rate is, including units. Again, we already calculated that there. And then the last thing is, what's your time frame? Those are the four things we need. On average, an increase, here's the rate, and then what's the time frame? And those are the four things we want for full understanding of the question. Let's take a look at another one, similar in scope, but a little bit different scenario. Now we have a pot of tea cooling. So we're filling coffee, now we're cooling tea. We're going to, let's see, number 7 and 8, as a pot of tea cools, the temperature of the tea is modeled by this function for 0 to 10 with our selected values. T is measured in minutes, so I'm going to highlight that right now. Measured in minutes. And the temperature is in degrees Celsius. Right there. Now, again, they tell us those in the table as well, so it's not like we have to sit there and go, I don't remember the units at all. They're in the table if we forget to highlight in the prompt itself. What we want to know is find the average rate of change of the temperature of the tea from t equals 2, there's my values at 2, to t equals 9. And so I want to calculate the change in output. Again, this is my output here. So from 60 to 44, that's a decrease of 16, so a minus 16. And then my input is time again. And that's from 2 to 9, that's a plus 7. So I'm going to calculate my average rate of change, which is negative 16. Oops. Divided by 7. I'm not going to find out what that is as a decimal because it is a disgusting decimal. It doesn't end or anything like that. So negative 16 over 7, that's reduced. I'm good with it. We're going to leave that. But we need to have our units in our answer. So this negative 16 represents a decrease in degrees Celsius per minute. Okay, so that's, again, our units. Number 8, using correct units, explain the meaning of your answer within the context scenario. So what does this all mean? So again, we want the first thing we want is that on average, the temperature of the tea and in this case we know it's a decrease because our average rate of change is negative. So the temperature of the tea decreases at a rate of 16/7 degrees Celsius per minute. We'll talk about something interesting that happened there in just a second. From t equals 2 to t equals 9 minutes. So let's double check that we have everything that we need. So we have on average, it's there. We have a decrease, okay, good. We have the rate, including units, and we have the mention of the time. What I want to talk about here is this, 16 over 7. Notice that my answer here was negative 16 over 7, but down here it became positive. We've already identified that it's a negative average rate of change when we said we had a decrease. So that's key there, that it's not just the number. We don't just transfer the number down. We want to make sure we're including a positive number. This tells us whether it's an increase or a decrease. And that's slope as an average rate of change.